Hey there, my name is Robert, and we've developed this ion exchange membrane. So we believe that this technology will change the world. It's not an understatement. It's not a claim based off just thin air. There's plenty of scientific studies, plenty of literature, plenty of research into this, and its potential in humanity's role in this planet and in life. Um, So this is again called the ion exchange membrane, and the implications of this, or the utilization of this membrane, have enormous impacts. Everything from energy storage, redox flow batteries, everything from fuel generation and electrification, so hydrogen production, gasoline production, and also converting hydrogen gasoline directly into electricity. So another way to understand this in layman terms is this can create gasoline from thin air, water, and electricity, and generate electricity directly from gasoline using air and gasoline. So it's called a fuel cell. If you're interested in looking more of what they are, specifically a methanol fuel cell, direct to methanol fuel cell. So you don't need an engine, you don't need a generator. You just have a fuel cell with these membranes, and you convert it directly into electricity. That unlocks flying cars, because flying cars requires that's gonna be in another. Each application of this technology deserves its own video, and I will do that pretty soon. But this is gonna be a quick summary, or not quick, probably a long one. We'll see. But again, these membranes have application in redox flow batteries, fuel cells, hydrogen production, general chemical production, mining applications. If you aren't aware, please watch my previous videos. If you are aware, I've developed a open source technology that you can extract platinum group metals, rare earth elements, critical minerals using salt water and electricity in a completely closed loop, environmentally friendly process. Tons of benefits, tons of benefits. But this has application in farming and health. So there's plenty of studies that show using ion exchange electrolysis, you can increase productivity by 40%, the yields by up to 40%, just by using a little bit of electricity in this. I can go on and on and on, but this technology will change humanity. And I'll make detailed videos explaining each process, explaining each method, explaining the actual calculations of what it takes to do X process, and how that same process can be utilized with this a lot more effectively. But the best understanding for people to have in order to understand why this is so important, why this is so revolutionary, is because chemistry is at the electron level. So whatever happens with electrons between two atoms or whatever inside of a molecule, that determines any reactions that occur. That determines what products are made, so on and so forth. So if understanding that lets you understand, chemistry is about electricity, about electrons. Once you understand that, then the best question is, okay, so how do I control this? How do I harness this? And that's what these are for. So this is actually considered a nanotechnology because it actually works at the nanoscopic level. You're able to selectively control which ions, selectively control how things are conducted, how things are done. The most simple process is simply let's say you have a positive electrode, a cation exchange membrane, and then a negative electrode. On the positive side, you'll have salt water. You run electrolysis through this. What happens is sodium ions move through the membrane, form sodium hydroxide on the negative solution. On the positive solution, chlorine ions get split apart and become chlorine gas, which has its own potential uses. So that is how fundamentally the simplest process of how ion exchange electrolysis works. But that's the simplest process, and again, the implications and research and potential that this has is enormous. Now, the first question a lot of people are probably asking is, okay, so why is what I have different? Why is what I have special, right? If there's plenty of research, plenty of literature, why has nobody gone and done this? Well, there is plenty of companies that utilize this membranes. You probably aren't aware of this, but these membranes are the key backbone to a lot of industries. because they make those processes just fundamentally efficient. But the reason why this technology hasn't had widescreen effects, right? Why you don't have a fuel cell in your car to convert gasoline directly into electricity to power to drive the motors, is because these are very, very expensive. If you don't believe me, go on AliExpress, look up proton ion exchange membranes, cation exchange membranes, and you'll find a sheet that's like a couple square inches, or even whatever, right? They come in many sizes, but you'll find a couple square inches cost a couple $100. So that's the reason why they're very expensive. Now we've developed something that is less than $1 per square foot. Less than $1, and that's at like off-the-shelf component scale. Me doing it in my garage scale. At an industrial scale, at mass production scale, we can produce this for pennies. So a fraction of a percentage of what these are industrially. Additionally, we've proven that these work in very harsh conditions. Again, our mining cells, which have many different chemicals in them, many different ions, many different metals, many different things in them that make just fouling very, very prevalent with these membranes. Also the very, very acidic conditions. We have pH 0 plus an ORP of greater than 1.6 volts, so a very high oxidizing potential in a very, very acidic environment that's capable of dissolving rhodium, gold, platinum, etc. And yet these, they don't care. Though I've literally ran them for like a year, and typically the only time I've seen them fail is if I get lazy and my electrode clumps up with let's say lead sponge or whatever, and it'll actually like short out. So it's actually called that term is called dendrites. Not gentrification. I'm thinking about gentrification, but no. It forms dendrites, which are just pretty much it's a technical term for whenever the electrode touches the membrane and it pokes a hole through it. So which is a physical thing, right? It's just me being lazy, but fundamentally, chemically speaking, I haven't actually seen really these foul up in a very long period. So which again proves that they're as competitive to industrial, commercially available membranes. So again, this and understanding again why I said the electron voltage level is half of the picture, but the other half of the picture is also understanding traditional processes. So a lot of people, for example, the mining industry, people really don't understand the mining industry unless you understand that it's a terribly inefficient, terribly wasteful process. And I love this one research paper that recently came out that the mining industry is a brownfield industry. If you don't know what a brownfield industry is, it's just let's say a land site that's just polluted and nobody can live there. Nobody, it needs to be cleaned up. So a lot of money spent, whatever. So the mining industry makes its money by creating brownfield sites. So that's fundamentally how most mining operations work. They use chemicals to, let's say, dissolve something. They'll reduce the chemicals, whatever, to plate it out, but there'll always be a little bit left in the solution, whatever. And so they can't really economically do anything with it because it's at such a basic level that you have to use other chemicals to, right? It's just you do it physically, chemically speaking, the traditional chemistry. There's nothing you can do. Best. So with these guys, the best thing they can do is just put it in a lake, build a huge pond, reservoir, fill it up with mining acid, and say, we hope this won't break in 20 years. And then it does, and it pollutes rivers, destroys the environment, and so forth, which is why one of the reasons why I open sourced my mining technology, because I saw the impact that almost every week I would see a new news report about a river, a dam getting spilled in Africa, in South America, even in America, causing killing everything in the river. But with this, you're able to, another way to understand this is that it controls entropy. So you're able to control entropy at the atomic level, split apart those molecules, and create reactions controllably using electricity directly. So instead of some company having to do a chemical reaction to produce this chemical, and then another reaction to produce this with, let's say 50 or 10% yield, do that 10 to 20 different steps to then send you, ship it across the country to send it to you to for you to finally utilize it on site for whatever applications you want. Well, you can use this, a little bit of electricity, and produce the chemicals you need on site. No delivery of chemicals, no nothing. All on site, continuously regenerated, continuously or completely continuously. Sorry, I probably should have written notes. And like I said, I'm just kind of going on a rant with this one, but this is definitely something that I really want to talk for a long time. Another thing to understand about ion exchange electrolysis is the electron volt level. So again, if there's anything you don't believe on what I'm saying, please Google it. And this is one thing that, like, please Google this, because this is such a crazy thing that you won't believe it until you look it up. So look up what is the equivalent of thermal temperature to 1 electron volt. Okay, look that up, and I'll give you a quick answer if you're too lazy, but it's over 11,000 degrees. That's right. So 1 volt of electricity is equivalent to 11,000 degrees. Yeah. This goes into its own entire thing, especially with the mining industry, about monotopic gold and this about pretty much it's gold that's like inside of a matrix structure, and you can't really melt it out or whatever, and the temperatures required to break those bonds are in the 7,000-8,000 degree temperature range, or in temperature range. So one of my biggest competitors, I would say, is the plasma technology industry. I absolutely hate plasma technology. Again, I'll make another video about that, but this allows you, and what's interesting also is ion exchange electricity. I recently also learned this, is that the formulas for plasma science is very similar, and in many cases identical to the formulas for ion exchange electrolysis, because you have free ions, right? That's fundamentally what occurs in ion exchange electrolysis, but it occurs at room temperature. And what people don't realize is that the voltage potential is so high that these molecules travel at the equivalent of 11,000 degrees without the overall system consisting of being at 11,000 degrees. Well, in this case, for if you're running at like 1 volt or whatever, right? But if you're running at a higher voltage, you could not theoretically, but fundamentally, physically, you are reaching these very, very, very high temperatures at the very controlled per atom instead of the whole system very inefficiently, right? So one great example I always like to say is there's this one company that's developed this plasma technology for mining, and their equivalent energy consumption is like thousands of dollars per ton. Absolutely insane. And like I calculated out that if they wanted to process like 1 ton an hour, I think, or something like that, it would have been the equivalent energy consumption of an AI data center. So yeah, pretty lot of like plasma just technology won't work out, but what's great about this process, and especially in our mining technology, is we produce those temperature potentials, those electron voltage potentials, those chemical potentials at very selective atomic levels, right? And instead of it increasing the whole temperature of the whole system, it just reacts specifically with the metal ions in the rock, right? Instead of having to increase the temperature of the whole system, it just selectively dissolves those specific ions. And also interesting is you can also use these membranes to then generate back that electricity. So kind of like a heat pump in chemistry. It's super weird. But anyways, point is you create that entropy imbalance, right? So you dissolve, let's say, gold or whatever in a chloride state, and you can actually run it through these electrolysis cells, plate off that gold, and regenerate your regenerate the power you just made. So yeah, it's and again, this might sound crazy, but there's literally companies out there that use ion exchange membranes to to generate electricity from saltwater and freshwater mixing. So whenever a river enters the ocean, that osmosis of salt and freshwater mixing, that actually has energy potential. And if you run it through these membranes, you can generate electricity. Again, the whole thing about that though is, these companies, a lot of them go bankrupt because these membranes are so damn expensive, they can't afford it. They foul, whatever, they have issues. But at the end of the day, it's expensive, right? And if it's too expensive, then you can't, if replacing these membranes costs more than the amount of energy they produce, you're not gonna go make a lot of money very quick. So I hope this video isn't too long. I hope this video at least gives people some understanding of the potential of this technology. One of the things that really frustrates me, or not frustrates me, but I say at a spiritual level, I'm trying to figure out and understand, is again the whole plasma technology field. There's a lot of people that are into it, and there's just a lot of scammers out there. There's a lot of fraud out there. There's a lot of this, and I'm trying to understand why, a lot of the times I talk to these people and they would prefer to go with plasma technology over this, which has scientific literature, which has scientific backing, which fundamentally proves. I originally thought it was just because, people like to, the moment they hear plasma, they're like, oh my God, this is so cool. It's plasma, right? It's plasma. Oh my God, it's damn plasma. How can you talk, bad about plasma? It's damn plasma, right? Like, everyone's like, so amazing, right? Plasma technology. But what I also learned and realized is a lot of these plasma guys and scammers, they when they talk and when they explain their technology, they're very they're not truthful. They don't talk about the downsides, and they only talk about the upsides. They only talk about this, but they never ever talk about the downsides. And a lot of the times I approach them, I ask them, hey, what is your energy consumption? How much energy does it take? And a lot of them will just, come up with excuses. Oh, we haven't looked into that yet. This and this and this and this. And that's like, how do you not look at the fundamental, right? How much, how expensive your technology going to cost to process X amount of material, right? How do you not do that? Well, they intentionally don't, because they realize that, if they did that, their process just would be uneconomically too expensive to run. And one of the things that I wouldn't say a fault, but my perspective, or the way I approach a lot of these companies and people is, I'm like, hey, listen, here's the technology I have, here's what it does right now, I know 100% it can do, and here's the downsides it has. And a lot of people, I feel like, hear that and they're like, oh, well, it has these downsides, and if it has downsides, that means it needs a lot of work and a lot of research and a lot of this. And a lot of people get discouraged by that, I feel like. And I was always confused by that. I'm like, why? Like, because from my perspective, the reason I was telling people these are the downsides is for them to understand that these are the only downsides it has. Holy shit, this is an amazing technology. And what I find really interesting, I had a really great conversation with two guys yesterday. They're from a very, very big company, but they were chemists, and they have some, I don't want to call them a research background, but they had scientific backgrounds. They knew a bit of engineering, a bit of chemistry, not a bit, a lot. But point is, when I explained to them my technology, immediately jaws dropped. They understood the potential of this, and seeing that, I'm like, okay, clearly there's a mismatch. Clearly, when I go to a layman person, when I go to a regular person, I explain them this technology, they just like in one ear, out the other. When I go to a chemist and explain, like I've went to ARPA already, I've explained that to them. Absolutely supportive, absolutely amazed, absolutely shocked. Whenever I go to a scientific background person, they're absolutely amazed, absolutely shocked. Whenever I go to a regular person, they're like, you can feel it, you can see it, that they're like, like, okay, and maybe they just don't believe me or what. But yeah, that's one thing I'm trying to tackle. That's one thing I'm trying to figure out this past week, this past couple weeks. I've been trying to understand like what makes that difference. Because again, I can't stress enough, this technology will change the world. And again, we're planning to open source this membrane very, very soon. are applying for some grants to help us finalize some last research, because we want to, get an actual research paper out there with some actual background or some, numbers behind this, so forth. But our company, Roel, is fully committed to open sourcing all of our stuff, all of our technology, all of our things. We already open sourced the mining technology, but we plan on open sourcing these membranes and so much more. The philosophy I have is that the potential and impact that this technology has is far greater than I can even control. And if I can just have a fraction of that benefit, I'm more than happy. I have a homestead, I have a farm, I have solar panels. I consider myself independent or financially independent, retired in my early 20s, and I've been researching and working on this technology, building this facility. As you see, all this I built myself. The only thing I had this whole building contracted out to do was the concrete, roof, and framing. The metal walls, outside walls, I did myself. The insulation, I did myself. All this welding, I did myself. These beams, I did myself. The mezzanine, I did myself. The concrete floor, I did myself. The cabinets, I did myself. Interior walls, electrical, everything here I did myself in a matter of a couple of months. That's just a person I am. I do a lot of things. I rebuild diesel engines. I'm into farming. Yeah, there's a lot of things I do, but I just I'm saying this just to demonstrate the point that I'm very flexible, and I'm a very capable person, and I see myself more than capable of tackling on this technology. I see a lot of new implications, a lot of potential with this technology. For example, with the refining cells, we have a current system that just uses selective solutions to refine, but I have a plan, a theory, an idea on how to develop a system where you have like 50 or 60 of these electrolysis cells just stacked, with in front of each other. And they're very small, they're very compact, super energy efficient. But you have a bunch of these electrolysis cells, and you run the solution through them, and it'll selectively separate each element to its purest level. So you have one cell with like pure rhodium, one cell with pure gold, one cell with pure silver, one cell with pure neodymium, one cell with just pure each individual element. Yeah, the whole damn periodic table, because my technology is capable of extracting, I think it's 53 or 53 or 54, 53 of the 60 critical minerals SEM TECH is capable of dissolving in a single step with a single unit, a chlorine-based unit. The 3 elements we can't extract if we just, it was like tungsten, I think, and 2 other ones we're capable of extracting with a different type of solution. Simply changing the acid, same like electrolysis cells, same like everything. And then 4 we're incapable of extracting because they're minerals. It was like barytes, graphites, fluorus something. I forgot those 4 ones, but they're raw minerals, right? Something you go and another one's like coal something, so right. Again, these are minerals. These are like rocks that you actually dig out from the ground. It's not really elements that you extract and get a final product in. So but with, again, with like one of them, the fluoro something, I forgot, but it ends up, I think it was calcium and fluorine. We can actually extract the calcium purely, extract the fluorine purely, and then react them together to create pure fluoro, whatever that was. So, again, the potential of this, there's no technology that can compete this. And I'm saying that from the laws of physics, right? From the laws of physics, because this works at the electron voltage potential level. There's nothing fundamentally more direct than that. If chemistry works with electricity, you have to use electricity directly to control it. Any other process that goes through any other way will be less efficient fundamentally, because you're not doing it directly, right? So anyways, I think this video is long enough. I hope I hope it has some. I hope some people find it interesting. Um, I hope somebody can recognize this potential. Um, I've been sacrificing the last 2 years of my life. Haven't had really a paycheck. Been living bare bones. Every single dollar I make, every single cent I make goes into this technology. I remember I was asking for some funds on a short, and I had some people say, "Why should I fund your expensive hobby?" And I was really depressed about that. Because I'm trying to develop this technology for humanity to make everyone's life better. I'm open sourcing this not even $1 billion, at least $1 billion, just in the battery, the redox flow potential. This has is in the billions of dollars, um, hundreds of billions of dollars, and I'm open sourcing it. And I have people saying that's just a very expensive hobby, not realizing that I can help them with their health, help them with their food, help them with their way of life, drastically, completely change everything, gain them independence, decentralize the system. So, yeah, imagine if you had a unit that can produce electricity in your backyard. That's what this does. Again, look up. If you don't believe me, look up methanol production. So pretty much what you do is use ion exchange electrolysis to produce hydrogen. You capture CO2 from the air, react that together with aluminum, copper, and I think zinc oxide in a pressure chamber, and out you get methanol. Methanol is, and then with the methanol, you can actually then react that with other catalysts. Um, it's and when I say catalyst, I just mean literally like a catalytic converter actually, because a lot of them are platinum group metals. These catalysts, for very specific conditions. But anyways, point is, with that methanol, then you can convert that to many other. You can create synthetic motor oil. You can create synthetic gasolines, diesels, etc., using nothing but water, air, and electricity. So. Yeah, I think okay. Final ending. I think that's it for today. Thank you for watching. If you have any comments, please drop them by. If you know anybody that might be interested in helping out, please, or just interested in sharing this technology, please drop it down. It's time that humanity starts utilizing this technology, and us not just living on a scarcity mindset and hurting each other over such stupid things. So anyways, thank you for watching. Stay subscribed. See you later.